Hey everyone, today we're diving into something that's a real game changer in how you approach your work, writing maintainable code. Now this is so much more than just a bunch of rules. It's really a way of thinking, a mindset that separates good developers from great ones. So let's jump right in.
All right, let me ask you something. Have you ever been in this situation? The boss asks for what seems like a tiny 5-minute change, but that simple fix just explodes into this 5-day nightmare. You're chasing bugs, fixing things that mysteriously break in other parts of the app. It is, without a doubt, one of the most frustrating things we deal with.
And you know, this is how it almost always happens. Look, nobody starts out trying to write bad code. We all have good intentions. But then the real world hits. Deadlines, shifting requirements, and slowly, piece by piece, our beautiful code turns into this tangled mess. It's what some people call software rot, and it's like the silent killer of productivity.
All right, so before we can fix it, we got to understand what's actually going wrong. Let's take a look at why code so often turns into, well, a mess.
So what does this mess actually feel like on a day-to-day basis? Well, it's when you fix one bug and suddenly two more pop up somewhere totally random. You know the one, the bug that won't die. Or it's when you're asked to add a new feature and you realize it's a massive project because everything is hard-coded and stuck together. These are the classic symptoms of tightly coupled code, where changing one thing has unpredictable effects everywhere else.
And this visual, this just nails it, doesn't it? A Swiss Army knife is awesome because every tool is distinct and does its own job. But when one piece of your code, one single class, is trying to do everything, manage data, handle user input, send emails, it becomes this useless, soldered-together brick. It's completely inflexible.
But here's the good news. This mess, it's not a life sentence for your codebase. There are proven ways to fight back. Let's look at the principles that help us build software that can actually last.
A lot of the answer comes down to a set of guidelines that experienced developers live by, known as the solid principles. And please, don't let the acronym scare you. These aren't rigid rules you have to memorize for a test. Think of them as a mindset. For today, we're going to focus on the big three, the ones that give you the most bang for your buck and can really change how you code.
Because look, anyone can memorize an acronym. That's the easy part. What really matters is getting the idea behind them. So to make it all click, we're going to use some simple, real-world analogies.
Okay, first up, the restaurant staff. Just imagine you're running a restaurant on a busy Friday night. How do you keep it from turning into total chaos? Well, you do it by giving everyone a clear job, right? The chef is in the kitchen cooking. The waiter is out front taking orders. The host is seating people. You would never tell your head chef to drop everything and start bussing tables in the middle of a dinner rush. Why? It'd be a disaster. Everyone has one job, and because of that, the whole system works smoothly.
And that right there is the entire idea behind the Single Responsibility Principle, or SRP. It's super simple. A class should do one thing and have only one reason to change. If you change a business rule, only the business rule code should change. If you change how you talk to the database, only the database code should change. It's all about focus.
All right, analogy number 2. This one is all about how you add new stuff to your code without, breaking everything that already works.
Okay, think about your phone. It works. It's been tested. If you want to add some protection or just change the color, you don't take a screwdriver, pry open the case, and start messing with the motherboard, right? Of course not. That's insane. No, you extend it. You add a phone case. The core of the phone stays safe and unchanged. And that is the core, the absolute heart of the open/closed principle. Your code should be open for extension. You can always add new things to it, but closed for modification. You shouldn't have to change the old stable code that you know already works. You add new features by adding new code, not changing old code.
Okay, last big analogy. This one's about building with replaceable parts. Think Lego blocks. What makes Lego so amazing? It's the standard bumps and holes, right? That standard interface. But this example here is even better. You would never ever hardwire a lamp directly into the wall. Instead, you use a plug and an outlet. That outlet, that's the magic. It's an abstraction. It separates the lamp from the complex wiring inside the wall. And this leads us perfectly into our last principle, the dependency inversion principle. It sounds complicated, but it just means your important high-level code shouldn't be welded to the nitty-gritty details, like one specific database. They should both connect to a standard plug, an abstraction. It's what lets you unplug one lamp and plug in another, or swap out one database for another without having to tear down the entire wall.
Okay,
So now you know the principles, but here's where we get into the senior developer mindset. It's one thing to know the rules, it's another thing entirely to know when and how to use them, and, just as importantly, when not to.
And this part is so important. These principles are tools, not commandments written in stone. The whole point is to make your code easier to maintain. If applying a principle actually makes it more complicated and harder to understand, you're doing it wrong. The goal is maintainability, not some theoretical perfect code. Just look at the difference here. On one side, you have this rigid, dogmatic approach, but on the other, you have the pragmatic mindset of a senior developer. It's all about making smart trade-offs. You use abstractions where you think things might change. You might keep two things in one class if they are always going to change together anyway. You do what makes sense for the project, always aiming for clarity.
Yeah, this quote really just says it all, doesn't it? Our job isn't to build some kind of perfect, abstract art. It's about building stuff that works, that solves real problems, that delivers value. And that takes judgment and the wisdom to find the right balance for every situation.
All right, so let's bring it all home. Because at the end of the day, this isn't about memorizing acronyms. It's about changing how you think about the code you write every single day. So what's the mindset? It's this. First, write code for the next person. And always remember, that next person is probably going to be you in 6 months, trying to figure out what on earth you were thinking. Focus on making things simpler, not just adding more and more layers. And finally, see it for what it is, a long-term investment in your project and your own sanity. So I'm going to leave you with one last question to ask yourself. The very next time you're about to write some code, just stop for a second and ask, am I building a solid structure, or am I just adding another knot to a tangled web? The choice is always yours. Thanks so much for watching.